What's surface area all about?
The area of all the sides.
Finding the area of all faces, then add them all up. Yep. We want to start with this rectangle here. What's the area of the front face?
3 times 12.
Yeah, 3 times 12. Now that's the front. Because that's the same face as the back, as you can see, I'm going to times that by 2, yeah, including the front and the back. Now, let's find the area of the side here. How do I find the area of the side here? 7 times, yeah, because if that's 3, that's 3. So I'm going to add the area of the side, because remember we've got to find all the areas and then add them up all together. Now, because this is the same side as this side, what am I going to do here? Times 2, okay? What 2 other faces are we missing that we got to find the area for and add them up?
Top and the bottom.
Top and the bottom, that's right. Let's do the bottom since the numbers are here. So that's just 12 times 7. And then what do I got to do after that? Yeah, times 2. So that's the basics. You've done that before. Yeah, yeah, 282 square meters. Surface area of a triangle. Let's find the area of the front face. What do I do to find the front face? What's the...
24.
What do I have to start with to find the area of a triangle?
1 over 2 times 8.
Half always first, yeah? Half times 24 and 7. That's the front, which is the same for...
The other side.
Yeah, so that's the front, that's the back. You're welcome, miss. And then just times by 2 because it's the front and the back. Yeah, same thing. Now let's find the area of this rectangle here. So that's 20 times what? Yeah, we're trying to find this rectangle here, but notice we don't know this length. So what do I got to do? We got to use Pythagoras Theorem to find, let's call that x, okay? So let's just find x on the side here. Yeah, that's right. So using Pythagoras Theorem, because it's the longer side, so x squared equals to 24 squared plus 7 squared. And then what do I have to do after that? What do I have to do for that? Yeah, square root that. Okay, so that's 25 meters here. So the area of this face is 25 times 20. Yep. All right. What other sides do I have to find? Let's find the bottom. All right. So this rectangle here. Yeah, that's just 7 times 20. Pretty easy. So plus 7 times 20. What else do I have to find?
The side.
Yeah, the side here. Yeah, good. So if I want to find that, that's 24, yeah, times, what's that?
20.
Yeah, because if that's 20, that's 20. Good. So that's 24 times 20, okay? I hope I put this in the calculator correctly. See how the top shape here, it looks like a square, but it's not a, how do we know that in this question, it is not a square? See these arrows, yeah, see these diagonals here? Usually if they give you the diagonal length within the shape, you've got to assume it's a what?
Triangle diamond. Isn't it? Rhombus.
Rhombus. How do I know it's a rhombus?
Because of the diagonals.
Yeah, if all sides are equal, like labeled, it's a rhombus. Yep. And to find the area of a rhombus, so let me draw it out here. So remember, a rhombus looks like this. Yep. And then you got the diagonal lengths, which is labeled x and y. Do you girls remember the area formula for rhombus? Yeah, or half xy. Yeah? So yes, it looks like a square, but if they give you the diagonals, assume it's a rhombus. Okay? Surface area equals, what am I writing? Let's find the area of the top. Half times 48 times 14. So that's the top, which is the same for the bottom. So I'm going to, times that by 2. Plus, now, we've got to find the area of this rectangle here. But in order to do that, I need to find x. How do you think we could find x here?
Pythagoras.
Yeah, Pythagoras of this triangle here. Yeah? They always bisect that right angle. So it's a right angle here. So to find x, what's that length there? 7, because half of 14 is 7. Good?
24.
Yeah, and half of 48 is 24. So once again, I'm going to use Pythagoras Theorem to find that. So I'll do it here. X squared equals to 24 squared plus 7 squared.
25.
Yeah, it's the same one as that. Nice and convenient. 25 millimeters. So this is 25 millimeters. So to find the area of this rectangle, that would be 25 times, what's that?
50.
Yeah, obviously 50, because that's 50 there as well. So 25 times 50. Yeah, and then there are 1, 2, 3, 4 all around. Yep, times by 4. Okay, yep. Okay, now this is a tricky question where a lot of students get wrong. What shape do you think this is first of all? Trapezium. Yeah, that's the first thing a lot of students struggle to see. Girls, think of this shape, rotate it in your head, and it's basically, what they're asking you to find is the surface area of this. All right, so let's find the area of the front. Now, do you guys remember? Very good. The height, the side, top and the bottom length for that formula?
Yes.
All right, so our job is to find these lengths. Okay, what do we have here? All right, so in this case, that's like your base there. Let's call that B. That's like your A there. What's my top length there? Yeah, if it's 1.3 there, it's 1.3 there. Okay, the only thing we don't know is the height, which is now this one or this one? 1 or 2? 1. It's a straight. Okay, how do I know that's the height? Because if you want to confirm, it's the length that's attached to the right angle. Yeah, right angle attached to the height and the base. Yep, so that's a slanted height. We don't want that. So in order to find that, we already know what that is. What is it? Yeah, if it's 7.6 there, it's 7.6 there as well. Good. Okay, that's nice and easy. All right, so the area of the front. All right, so let me just write the working out. So I've got surface area equals to h over 2. What's my h? Yeah, so that's 7.6 over 2, bracket a plus b. That's these two, 1.3 plus 2.2. So times by 2 for the front and the back. Yep. Now, plus. Let's find the stuff that we can find easily. Let's find the area of this side rectangle. It's meant to be a rectangle, even though it doesn't look like it. Yep. Yeah, so 1.3 times, 4.3, yeah. Because if it's 4.3 there, it's 4.3 there. So 1.3 times 4.3 plus, let's find this rectangle. It's meant to be a rectangle once again. What is it?
4.3 times 2.2.
That's right. 4.3 times 2.2. Okay, the one face that is usually incorrectly calculated, or what is that last area we need to find? We found that, we found the back and the front.
The bottom one.
The bottom one, that's right. Okay, now if you actually physically think about this, it is actually a rectangular base. Yeah? Can you picture it? It's just a rectangle in real life. Now, in order to find this area, I need to know, let me do it in a different color pen. I need to know what this is. And I need to know what that is. Yes?
Yes.
What's that?
4.3.
Yeah, if it's 4.3 there, it's 4.3 there. That's fine. Yep, because that's the same. This is a tricky part. Let's call that x for now. How would I find x? Can you see? Yeah, good. That's actually the correct answer.
Can you do on the?
Yeah, I'm going to show on both. Okay? Now, the reason why I need that, let me show you what this looks like here. We're finding this x. Yep. Right now, my A is 1.3. My B is 2.2. My height is 7.6. Right. Now, in order to find this length, what she's saying is, let's cut this trapezium like this. Okay? So if I cut it like this, that gives me a right angle triangle that we can use to find Pythagoras.
Yeah.
This is 7.6, because that's the same. Now this, right there, yeah, it's 2.2 minus 1.3. That's right. Which is, 0.9. Okay? So that's the tricky part which a lot of students find hard to visualize when it's tilted on the side. So in order to find x now, it's pretty obvious. It's square root of 7.6 squared plus 0.9 squared. Looks like a 0 to 6. Okay? 7.7 meters. All right? So girls, that's 7.7 meters. We're done now. What do we need to do? Come on, final part. What do we got to do? Add the area of the bottom area, which is 4.3 times what? 4.3 times? Good. Okay? And you just need to put that in the calculator.